Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 4 by 39 from Engineering Mechanics, Statics, 9th edition by G.L. Meriam, L.J. Craig and Jen Bolton. Statement of the problem is determine the forces in member CD, CJ and DJ. So in this truss need to find member forces CD, CJ and DJ. So because for the whole of the truss, so member forces only in three members are required. So then the best suitable method to analyze this truss is method of sections. So these are steps to find member forces using method of section. So need to plan a cut, and that cut must pass through the target member. So the target members are CD, CJ and DJ. So the possible cuts are, the first possibility is there, that is number 1. The second possibility is there, number 2. So now the cut 1 is going to pass through two target member CJ and CD. Cut 2 is going to pass through two target member DJ and CD. It is not possible to solve this problem using single cut. So need to apply cut at 1 first, and once it's being calculated, so then we can use another cut. Or there is a possibility that once member forces at cut 1 are calculated, so then we can use method of joints. So for this one, because if I'm going to select any side of, let's assume I'm going to use that cut 1 first and then followed by, I'll see that if it is a method of joint is going to be applied there, or method of section after that. So now uh, on the cut, I need to uh, select any of that side. But if I'm going to select right side, so I need to know whatever is the tension at I. Or if I need to select left side, so I need to find that what is reactions at that pin support, because the pin support, so there must be two reactions. So I need to find support reaction first. Steps to find reactions. So need to draw free body diagram of the whole truss, ignoring internal member and replacing supports with reaction. So there is a roller pin support. It has two reaction Rx and Ry, and there I is joined by a link. So there will be one tension or one reaction at I. So first I need to draw its free body diagram, and then need to apply conditions of equilibrium, sigma m equal to 0, and then sigma fx equal to 0, sigma fy equal to 0. So I'm going to draw its free body diagram. So that's the free body diagram. So at point I, so IY is upward, otherwise you can choose any direction, and then finally once the directions are chosen, so then you can use the interpretation like choose any direction, assume suitable direction of our reaction, and once you have calculated, then you can do the interpretation. The sign a positive value confirms assumed direction, so whatever you have chosen. So if answer comes as positive, so assumed direction is correct, and if a negative value, it means that your chosen direction is not correct. So then I have assumed the direction, and now I'm going to find these reaction. So the best one is I can go for sigma fx equal to sigma m equal to 0 to choose a moment point that has most unknown. So it is going to eliminate ax and ay. So now about point A, so the moment due to all those loads is in clockwise direction, and at B it is L times 3, at C it is L times 6, at D it is L times 9, at E it is L times 12, at F it is L times 15, and then at G it is L times 18, and all are in clockwise direction. So all of these are taken as negative. Now IY is going to produce moment in anti-clockwise direction, whereas all these are in clockwise direction. So IY times by 12 is positive. So I have assumed that anti-clockwise as positive and clockwise as negative. So after simplifying it, it comes as 12y is equal to 63, L is equal to 0, and Iy comes as 63 over 12L, which is positive. And this positive mean that assumed direction is correct. So then I'll go for sigma Fy equal to 0. So now sigma Fy equal to 0, so Ay is acting vertically upward, so that is positive. Iy is going to vertically upward, that is positive. And then all those six L's are going to act vertically downward, so they are negative. So Ay plus Iy minus 6L equal to 0. So then Iy I have already calculated that 5.25 L. So by substituting that Iy there, so Ay comes as 6L minus 5.5 L, so that is 0.7 L. So now Ay is again comes as positive, so it's mean that assumed direction for Ay is also correct. Then I need to find Ax. So for that Ax, I'm going to use sigma Fx equal to 0. For sigma Fx equal to 0, there is only one force and Ax is equal to 0 because there is no other horizontal force. Okay, so Ax in the because there is no horizontal load acting, so Ax is equal to 0. But sometime what will happen, because when the sports are not symmetrical, or the sports are not at the same level in horizontal or vertical, so applying simply sigma Fx sometimes give Ax is equal to 0, so which is not true. So otherwise I can find out uh, Ax by taking moment about any of the point. So now Ax can be calculated again using moment about point I, and for I, Ax, that is the line of action of Ax, and its perpendicular distance is 5. So Ax is going to produce a moment in anticlockwise direction. Now that is Ay, so that is the line of action of Ay, and perpendicular distance from I is 12. So Ay is going to produce a moment in clockwise direction. Then uh, that L at C, L at D, C, and B, so they are going to produce moment in anticlockwise direction. And then E, L at E is passing through I, so it's not going to produce any moment. But at F and G, so they are going to produce moment in clockwise direction. So then I can write that 5 times Ax minus 12 times Ay, so that is 12 times Ay. And then moment at uh, load at D is 3L, then at C is 6L, at B is 9L. And on the other side, so they are all positive. And on the other side, uh, load at F and its perpendicular distance is 3. So is in anticlockwise direction negative, so 3L, and then at G, that is L times by the perpendicular distance is 6. So that is 6L. And after simplifying and solving, Ax comes at 0. So Ax is equal to 0. So now a simpler side of the cut. So right side, it has 4 loads are known and now 1 reaction. So altogether 5. And then left side that has 2 loads known and now I have calculated reaction at A. So there is only 1 reaction at A. So I'm going to choose left side for the analysis. And then I need to draw the free body diagram of left section and need to show all loads and reactions on it, and then unknown cut member forces assuming intention. So unknown cut member forces are CG and CD. So I'm going to assume that as tension, but there is also one JK is also present. So I'm going to assume that intention as well. Free body diagram of left section is being drawn here. So at AY, the load is acting vertically upward because it is here I have calculated that as 0.75 L, and two loads at B and C, they are acting vertically downward. So JK is in tension, CJ in tension, and CD is also in tension. So the next one for CJ is an inclined member. So for CJ, I can, to find the angle or to find the component for CJ, So I can use triangle CJD, and in triangle CJD, its horizontal side is 3 and its vertical side is 4. So next I'm going to apply conditions of equilibrium there, apply conditions of equilibrium and cut part to find unknown. So usually for method of section, so it is good to start with sigma m equal to 0 because it's going to eliminate most of the unknown forces. And then to apply sigma fx equal to 0 and sigma fy equal to 0, I'm going to apply conditions of equilibrium to this cut. Before applying conditions of equilibrium, I need to resolve Cj into its components. So then it is using that small triangle. So Cj can be resolved into its two components by moving it towards nearest horizontal and nearest vertical Cjx, which is acting towards positive x-axis. So that is positive, and then Cjy is going to act in upward or positive y-axis. So it is positive. So now I'm going to take moment about point C so that uh, that Cj and Cd are eliminated, and I can find that Jk. So to find moment about point C, so Jk, the line of action of Jk is there, and perpendicular distance is 4, and Jk is going to produce a moment in anti-clockwise direction about point C. So the next one is a load at B. So the perpendicular distance, that is the line of action at B, and the distance, perpendicular distance is 3, and then that load L is going to produce moment in anti-clockwise direction. And then the next one is 0.75 L. So zero point 0.7 I, that is the line of action of 0.75 L, and it is going to produce a moment in clockwise direction. So assuming clockwise moment as positive and anti-clockwise moment as uh, assuming clockwise moment as negative and anti-clockwise moment as positive, so I can write there starting from that L times by 3 with the positive, and then 7.5 L times by 6 as a negative, and Jk times by 4 as negative. So it is 0. So then I can simplify this equation to find Jk. Now 4Jk comes as minus 1.5 L, and Jk is minus 1.5 over 4. So that comes as minus 0.375 L. So I have calculated now Jk, and now next I can apply sigma fx equal to 0 or sigma fy equal to 0. So because there is only one unknown in vertical direction, so then I can apply sigma fy equal to 0 to find Cj. And to apply sigma fy equal to 0, so Cj is positive. This L at C, load at C is negative, at B is negative, and reaction at A is positive. So it is plus Cjy minus L point plus 0.75, and then solving it, it is possible to now Cjy. So Cjy, it can be written into components as Cj times by 4 over the diagonal. So Cjy is y component is in the triangle. So vertical side divided by hypotenuse or diagonal. So Cj comes at 4 over 5 equal to 1.25 L. So Cj comes as 1.25 times by 4 divided by times by 5 divided by 4. So Cj comes as plus 1.5625 L. So now Cj is calculated. The next one, I'm going to apply sigma fx equal to 0. And for sigma fx equal to 0, so one is Cjx in horizontal direction, the other one is Jk. Both are taken as positive. And the third one is Cd. So then sigma fx is equal to plus Jk plus Cd and Cjx. So Cjx again here, so Cj times by 3 over 4 horizontal side over the diagonal. So now Jk is known, Cj is known, so I can find Cd. So Cd comes as minus Jk. So Jk is already minus. So on the other side, minus minus will become plus, and then minus CJX. So CJ is 1.6525 times by 3 over 5 horizontal side over the diagonal, and then after simplifying, CD comes as minus 5.5625L. So now whole of that section is being analyzed. So once it is being analyzed, so then I can write the answer by interp- using interpretation of that. So interpretation, the sign of unknown member forces, a positive value indicate tension and a negative value indicate compression. So JK is negative, so that is in compression. CJ is positive, so that is in tension, and CD is also negative, so that is in compression. So now these are the answers: CD in compression, CJ in tension, and then JK in compression. So the member in tension or compression, so they always remain in tension or compression. So member, if once is calculated, that is in tension, so that will remain in tension. So now member forces CD and CJ are calculated. So the next one, I need to find DJ. So to find DJ, there are two possibilities. Either I pass a cut here at 2, or otherwise there is a possibility I can just select joint J, because at joint J now I have that JK known and CJ known. At joint J, I can use method of joint to find DJ. So that's the method of joint. So select a joint with at least one known force and less than two unknowns. And then need to isolate the joint, draw a free body diagram, and assume all member forces act in tension, arrows away from the joint, and then apply equilibrium condition sigma fx sigma fy equal to 0 and resolve inclined member. So because for JC is inclined member, so we already know its angle. So simply I'm going to solve J using method of joints. So I have isolated joint J, and that is IJ and DJ. So these are two unknown, and JK and CJ are unknown. So CJ can be resolved into its component as CJY and then CJX, and then again CJ component I can use using rule here. Now IJ is not required, and then for DJ, because it is in vertical direction, so there is only one unknown in vertical direction, so I can apply sigma Fy equal to 0 to find DJ. So that is DJ acting vertically downward negative, CJY is acting vertically downward and negative, and then CJ is 1.5625. So I have the value and the its component I can calculate. So then DJ comes as dj is equal to minus cjy, and minus cj times by vertical component I'm going to go for that, so 4 over 5, and then finally dj comes as minus 1.25 L. Ij is not required, so I'm not going to calculate that. So dj, because it is negative, so it will be 1.25 L in compression. So now dj is calculated, cd, and then all the answers are calculated. So CD is 0.562 L in compression. So CD is 0.562 L in compression. The next one, CJ, is 1.562 in tension. So CJ is 1.562 in tension. And finally, DJ is 1.25 L in compression. So the answers, they matches with the back of the book. So this is how to solve this problem. Thank you very much for watching.